Hello everyone, I'm Mohammad Mujad Samrahi. I will be taking you through the Webots tutorial. In this video, we will be looking into Webots environment setup, and we will be interacting with the dynamics of physics and how certain objects interact with the principle of physics. We have divided the physics interaction into two parts. In the first part, we will look into density and mass. Okay, so to start off, this whole video are a sequence of videos where we will try to provide lectures for and make it easier for you to understand how we can uh, perform our certain tasks in Webots. So as you have already seen, this is the sequence to or a sequel to the video that you have already seen, which is the dynamics of collision, and this will be after that. So as you know, we have already designed these four objects before in in other videos such as collision. So we will be continuing from that, and we will continue using the same for objects that you have seen before in other videos. So to start off, we will like to at first denote why do we need physics, because without understanding physics or without providing physics, objects will not have mass, objects will not have density, and they will certainly not react to gravity. So to mimic real life scenarios, we need to provide physics to certain objects so that the interaction medium that they go through can be more realistic. Okay. To start off, I will like to show you how we can give physics to certain objects. So these are the four objects that you have previously seen. This was created in other videos. I will not go through how to create these objects. We have these objects. These objects initially will not have any physics applied to them. So we need to start giving them physics. To start off, we will like to give physics to the sphere first, and it will be the same for the all the other objects as well. So how do we give physics? You left click on this, it automatically selects DEF sphere solid. You go into this and you scroll down and you see the physics is null. Click on that. You can double click here, or you can click here and you see the plus button. So yeah, you click on that, it adds a new object. In this case it's physics. So select physics here, you just add physics and it will be done. It might take a second or two depending upon your hardware, but more or less it should be done. So yeah, here you have already added physics to the system. So if we scroll down, and now you would see physics is not null, physics is added, right? So if you also open that tab, you would see there are certain subcategories in physics. So density, mass, center of mass, inertia matrix. For today's class, we will look into the first three of these criteria. We will not look into inertia matrix because we believe you do not need this currently right now in the projects that you will be pursuing it. Also, let's start with center of mass. So center of mass is basically your center of gravity, the coordinate through which the whole weight acts upon, right? So obviously, initially, if you double click on it, you would see the center of mass should be the origin or the center of the object where the coordinates, the x y z coordinates, because we are talking about a 3D plane, so there will be three coordinates. All of those coordinates would be at 0. So to mimic real life scenarios, usually all of the center of mass or the center of gravity would be at the origin, and so we do not need to change that. So we will keep this center of mass as it is, because if we change that, we will basically change how certain objects behave, and or like how certain objects behave through gravity. So we will keep that same. So for your projects or even for this demonstration, we will not change the center of mass. We will keep it as it is. It will be through the origin. Okay, so now we will talk into density and mass, and we will go in depth and describe how these things act. So to start off density, so initially you can see the density has been set to 1000 and the mass has been set to -1. So you see the volume of these objects are fixed. If you look into the formula of density, density is equals to mass divided by volume. So the volume for these objects will be fixed. You cannot change it. You see, like the volume is fixed for this object. So if you provide a density to this object, it will automatically like correct itself to provide the accurate mass that it is. If, for example, if this volume is 10 meters square, and you put the density as 1000, it will calculate the mass, and that will be the mass for this object, right? Provided the formula density equals to mass by volume. So in that regard, you can either provide density or provide mass in these circumstances. Whatever you provide, if you're providing density, you have to put mass as -1. If you're providing mass, you have to put density as -1. In this regard, the unit for density is kg per meter cube, and for here, by default, it's usually put to 1000, which necessarily means this object, this sphere object, is made up of a material which has a density of 1000 kg per meter cube. Okay, so in that regard, they will somehow calculate the mass, and that's how it's gonna accordingly, like, behave. So by setting a density, I can also set a mass for it. It basically means I have a sphere which is made up of a material which has a density of 1000 kg meter per kg per meter cube. Okay, so let's see how it behaves. Because now it's physics, physics has been applied to these objects. You have to believe, like, these all of these objects will follow the principle of physics. So whatever object you have, if you apply a force, that object will move, right? If you overcome the static friction and apply a certain amount of force, the object will move. So in Webots, we can apply force to a certain object. We can also apply energy in the form of moment. Energy is basically, the definition of energy or work done is basically force into distance, right? So the unit should be Newton meter. You can see we can apply moment here, given that we will be considering this specific object as its pivot, and we can apply moment, and we can also apply force. Let's see how to apply force. Because this object now has physics, we cannot apply force to an object until or unless you have given it a mass, right? Then you can only apply uh, specific forces. So to apply forces, what you need to do, press on Alt on your keyboard, and then left click and drag it, and you see there is a force button. The more you drag, it increases the amount of force, and when you let go, you would see that it will move, right? Okay, there are times the system will lag, so be careful. So right now my system is lagging a bit. So let's see. So let's decrease the density of it. That means the object will become lighter and it will move at smaller forces. Oh, the thing is I haven't started the simulation. Right now it will move. See, it will start moving, right? Okay, so obviously you need to start the simulation to see any process that's happening. So you see these objects, my sphere moves, and whenever I apply force to it, alt plus left click and drag, but when it hits any other objects that has no physics, you see it bounces back, because these objects do not follow the concepts of physics. It's just like a solid cone or a solid cylinder. So right now only the sphere follows the rules of physics, and you can apply a force to it. Similarly, you can also apply moment to it, but remember, when you're applying moment, it's the multiplication of your force and the distance. So do not initially apply a huge amount of moment and you'd see your ball just bouncing off this field that you have created. It's apply a little bit of moment, you see, like, you would see the ball bouncing, and obviously you can make it jump as well, right? So things like that. Okay, so this is how we can apply a moment to a ball or to a sphere or any object by changing the density, and by changing the density we have provided mass for this object, and so we can apply moment, and we can also apply force. For moment, it's left click, alt plus left click and drag. Sorry, for force, alt plus left click and drag, and for moment, alt plus right click and drag. Okay, so hopefully this stays inside. Yeah, it did. Okay, all right. So this will be how we can adjust a mass by fixing the density. Now we can also directly adjust the mass without changing my density. So for that reason I need to change the mass. So let's say I give the mass of 10 kg for this ball. So you see it instantly showed you a warning. The last warning that it showed was for this. What we did was we applied both density and mass for the specific sphere solid. We cannot do that because that basically violates the rule, right? Because your volume is fixed, you can't change that. We have told you. You cannot put density and the volume, the mass at the same time. That contradicts the whole equation. So what it does is basically it will ignore the density. So it's better to like actually ignore the density and give this value a -1. So it will actually, I'm telling the system to ignore the density whenever you put -1 in any of these values, because mass and density they only take positive values. If you put -1, it basically ignores that. So previously we have put -1 in mass to ignore mass. Now we will actually like to put -1 in density because we are providing a static mass to this object. So it means like whatever the density is, it will obviously fix itself or like have a value for its density. The mass of this object will be 10 kg. So similarly, I can also now I can now put force to it, just like before. I can apply moment to it, just like before. Okay, the procedure will be exactly same. So you left click on that, and yeah, boom. All right. So this will be it. If you apply too little moment, it will not move because obviously you need to overcome static friction as well. Okay, now we have seen how objects can move when you apply the force. In this part, we will now look into how multiple enduring collision, if you have multiple objects. Yeah, we have seen previously, like when this sphere was like in collision with this other object's cone or cylinder, they will not move because they're just solid objects, and these objects do not follow the basic principle of physics. So now we will also make them, we will also provide them these objects with physics, and let's see then how the collision will change. So we have two objects. We will make this object very light, this cone very light, and see how this behaves, and we will make this cylinder very heavy, and let's see how it behaves as well. So what we need to do is also provide physics. You can double click here as well. It should uh, bring this prompt message. Just add. I told you it might take a while, and my system is really not that great as well, so it does take a while. But if it runs on my system, it should also run on yours, so there should be no problem with that. It just might take a while. Okay, so I've provided physics to this. Let's change the mass. I'm going to make it very light. So yeah, mass, I will change it to, let's say, 0.5 kg, and then I need to put density as -1. So yeah, very cool. So let's see how this behaves. So I will just bring it over here. Okay, so directly in line with this object, this object is very light. And another example is, you see, if z axis, this y axis yellow one is for basically your height. So if we take this up, this object is up, what do you think should happen? Because there is gravity, right? It should fall down, right? You see, this object instantly falls down because gravity also plays a major part. This plane is solid, otherwise it's this empty space, it cannot stay there, it falls down on its own. So now what we will do is we will have a collision. Initially, you have seen when this object does not follow the principle of physics, it will just bounce back. Now you would see all, see, this is moving on its own, right? Now let's hit it again, this time with a little bit of more force. Oops, I have thrown the ball off. So let's bring back the ball again. So for that, we can just discard everything, and here comes the ball. So let's again make this solid. Now we will add physics to it. And the mass 10 kgs, density as -1. Similarly, now we will use this cylinder. We have seen this when was 0.5 kg, it just rolls with it because this is a much lighter object than 10 kgs, so it goes with it. Whatever. However, if we make this cylinder much more heavier, let's see what that what impact that does have. So yeah, I will also provide physics to this cylinder. Done. And I will increase its mass. Let's make it 100 kgs and the density will be -1. All right, so if that's the case, let's mimic the exact scenario. I will bring the ball here. I can move it a bit here as well, and now we bring it here. So you see this ball, the sphere has a mass of 10 kgs, and this cylinder has a mass of 100 kgs. So when it hits this cylinder, it's supposed to like as it the cone with the when it was hitting the cone, which had a mass of only 0.5 kg, it rolled with it, right? But when you would see when it hits the cylinder, it's supposed to, like in the sense, supposed to block the sphere. So let's see how does that happen. So we will just see. It does not, it gets blocked because you see different mass behaves differently, and you have seen here how even the collisions will vary, and how central gravity plays a part, and how mass different masses different impacts as well. And you also see if you increase the mass to, like, to a huge extent, you would see this mass, because this floor also has a density, right? It cannot hold it, right? It will sink down because it cannot hold this and will just go down through the plane. Given that the plane, still my floor does not follow the rules of gravity, otherwise it would have broken down as well. But yeah, it just went down because it could not, this surface could not hold on to a mass of that degree. So that's all. In the next video, in this second part of this video, we will look into how friction plays a part, and, like, in holding objects or in moving objects. Thank you.